In the last video, we introduced beam deflection and bending. Here, we will try to explain what's happening inside a beam when it bends. Suppose we have a very simple beam. It has a pin support on the left and a roller support on the right. When a vertical load applied onto the beam, it bends. To better understand how the beam actually bends, we can divide the beam into many small segments. To make it easier to look at, bending deflection is enlarged many times. Here is another angle for showing how the beam bends. When we look closely at the end cross-section, which is originally vertical, rotates when the beam bends. We also notice that the middle line does not move, but points on the top surface move toward the right, while all points on the bottom surface move towards the left. Every small segment of the beam move under bending. We can look at a single small segment to understand more about the bending. Now, let's look at a single segment. When the beam bends, every small segment will bend, as shown in the screen. We notice that, first, the two side cross-sections, which are originally vertical, rotate when the beam bends. Second, the upper surface, which is originally a flat plane, becomes a shorter curved plane, while the bottom surface becomes a longer curved plane when the beam bends. So, we may ask ourselves a very important question: why the top and bottom parts of the beam would become longer or shorter? What causes such changes in length? The answer is very simple. Tension force makes things longer, and compressive force makes things shorter. Therefore, we can deduce that there are tension or compression forces acting on this segment. The upper segment is compressed shorter by the horizontal compressive forces. The lower segment is pulled longer by the horizontal tension forces. While the middle plane, although its shape changed, its length remains the same as the original plane, and there is no tension or compression at the middle plane. When all these segments are connected together, we can see the whole beam bends. The middle plane, which has the same length as before, carries no horizontal compression nor tension on this plane. It is called the neutral plane. The beam materials above the middle plane become shorter than the original length. They are under compressive forces, and the top surface has the largest compressive force, while all beam materials below the middle plane become longer because of tension forces, and the bottom surface has the largest tension force. Now, assume that, for the same beam, the load is applied horizontally. Then, the beam will bend horizontally. we can look at the beam from another angle. In this situation, the end cross-section is rotated in horizontally. Similar to what we discussed previously, points on the middle vertical line do not move, while the points between the blue line and the yellow line move towards right, and the points between the blue line and the red line move towards left. In this case, the vertical middle plane has no compression nor tension. This plane becomes the neutral plane for horizontal bending. The yellow surface becomes shorter and have the largest compression. The red surface becomes longer and have the largest tension. This is very similar to the previous situation, except that the beam bends horizontally